All right, number 11. Dante is getting ready to play a game in which he spins a spinner with 6 equally sized slices numbered 1 to 6. The spinner stops on a numbered slice at random and never in between. This is the game. Dante will win $1 if it lands on 1, $4 if it lands on 2, $7 if it lands on 3, and $10 if it lands on the number 4. But if it lands on 5 or 6, he loses $8.75. Now, since there are 6 pieces here, what is the probability that it will land on any of these numbers? Well, they are all equally likely to occur. Ooh, look at that 5. So it's a 1 in 6 probability. So the probability of any of these numbers is a 1 out of 6 chance. So that's good to know, because we've got to do the expected value. Expected value is normally represented by a big O E with an X, and it just represents the long run average. If Dante played this game 1,000 times, what could he expect in the long run? So he could win $1. He's got a 1/6 chance of that. He could win $4. He's got a 1/6 chance of that. He could win $7. Got a 1/6 chance of that. You win $10. A 1 in 6 chance of that. And these games are all games of chance. Or he could lose it all. He could lose $8.75. He's got a 1/6 chance of that. Or he really has a 2/6 chance because he could do it again. So I'm just going to slide it here. Minus 8.75 times the 1/6 chance. Now, as you work out this type of a problem, it might be in your best interest to create yourself a little table of all your outcomes, and then the probabilities of your outcomes, and then the payout, so that you would multiply your probability times your payout. You don't have to necessarily multiply it by the outcome, because multiplying it by 1, 2, 3, 4, 5, or 6 isn't really going to do anything. But this is just your outcome, and this is the probability of your outcome. Now, how do we calculate probability? It is part over the whole. What part of the circle is 1? 1 out of 6. There's 1 out of 6 for each one of these, because there's only one circle labeled that. But if there were 2 2s, you would say 2 out of 6 if it were a total of 6. So that's how that goes. Now, looking at all of these terms, notice that they all have a 1/6. So I might make it easy on myself and factor out the 1/6 and just add all the other numbers, like 1 plus 4 plus 7 plus 10 plus negative 875 plus negative 875, and see what you get. Or you can enter it into the calculator that way. Whatever you want to do. I'm just trying to show you little shortcuts and make it a little quicker for you so you could come back and circle around to those that you might have a question about. But let's keep going. 1 plus 4 plus 7 plus 10 minus 875 twice. I'm just going to put a 2 right there. Enter 4.5. 4.5 divided by 6. 75 cents. So this is equal to 0.75. Thank God he didn't have to pay $1, because then he would have lost 25 cents. But he didn't have to pay anything, so that's great. But as a side note, let's talk about the lottery. See, this is kind of how the lottery works. But most tickets don't have a 1 in 6 chance of winning. You have like a 1 in 6 million chance because of all the tickets that they're selling all across the state of North Carolina or wherever you play, if you play. The expected value of playing this game is $0.75. In the long run, he can expect to gain $0.75 per $0.75 per spin. So he could win 75 cents each time he spins. Now you might say, how could he win that? Because that wasn't one of the winning things. This is an average over time. So if he played this game 100 times, he could expect to win $75. If he played 1,000 times, he could expect to win $750 on average, based on all the times he would win and all the times he would lose. Number 12. 15 cyclists were each asked the number of miles they biked. So you've got these number of miles. You could come over here and mark off all the ones that go from 0.5 to from 0 to 5. So 1, 2, 3, 4, 5, 6, 7. How many go from, I guess you could say 6 to 10? 1, 2. How many go from 11 to 15? 1, 2, 3, 4. And how many go from 15 to, well, 16 to 20? 1, 2, and that accounts for all 15. Or you could go through the list, as I would recommend. I would write all these numbers down in this little table, and then I'd make little tally marks. And as you go down through, you'd have 4 and 8 and 4 and 14 and 5 and 20 and 19 and 13 and 3 and 2 and 7 and 14 and 12 and 5 and 5. See how you get it? It's not too fast, not too slow. I mean, you could do it either way. This was our frequency distribution. Now we're going to use this information to help us make a frequency polygon. Now, frequency polygons are just easy to make, but when you have a grouped piece of data like we've got here from 0.5 to 5.5, what are you going to put on the axis? You're going to put the midpoint on the axis. So you got to find the midpoint of each class. Now, you could do this one of two ways. First way is to take the upper and lower limit, and in the first class is 0.5 plus 5.5. And I'm going to tell you that these are the class boundaries. You have to get used to looking at group data. Sometimes it starts with a different number, but when it starts with the same number that the prior class ended with, I know that these are class boundaries. And that just means that these numbers are not in the set of data at all. But anyhow, how do we find the midpoints? You add them together and then you divide by 2. That gives you a 3. So we found our first midpoint was 3. Now, because we know that the class width is 5, I know the next midpoint is 8, because 3 plus 5 is 8. And then, excuse me, 8 plus 5 is 13, and 13 plus 5 is 18. So these are my midpoints. So these little dots are where you're going to put the midpoints. You're going to have little boxes underneath them, and you would type a 3, a 8, a, and put another dot here, a 13, and a 18. Now, what do? We know that our class frequencies for the first class went up to 7. So we would pull this dot all the way up to 7. And what would happen is this line that we don't see would start from here, and it would go right up there to that point. We'll make all these points blue so they can look real fancy. And then here at 5, we would go to 2. And then at 13, we would go to 4. And then we would pull this up to 2. And again, these lines that we can't see would actually emerge, and they would go right there, and then this one would go up here, and that one would go here, and then it would connect right there with the bottom. And that's your polygon in a nutshell. All right, number 13. Avicenna, a major insurance company, offers a 5-year insurance policy to 65-year-old people. The holder of these policies dies before the age of 70. The insurance company has to pay out $26,500 to the beneficiary. Now, executives are considering offering these policies for $497 each. Suppose that each holder of a policy has a 2% chance that they'll die before the age of 70 and a 98% chance that they will live to the age of 70. So these are our two outcomes. You're either going to die before the age of 70 or live to and beyond the age of 70. Those are our outcomes. What are our probabilities? So the probability of dying before the age of 70, I hope you know, is 2%, 0.02. And the possibility of living to the age of 70 and beyond is 0.98. Folks are taking good care of themselves. Now, what is the payout? See, this is a real practical one. The payout will be this. The families are going to get $26,500. So it's a yippee yippee yah to them, but for the insurance company, they just lost $26,500. And if the person lives to 70, then they don't have to pay out anything. So that's 0. So we do our expected value the same way. 0.02 times negative 26,500 plus 0.98 times 0. Because again, they don't have to pay anything out. Now, if we punch this into our handy dandy calculator, let's see what we get. 0.02 times, and again, this is a negative because the company is losing this money because this person died beforehand. Negative 26,500. Negative 530. So this is their expected value. They losing $530 every policy. This is not a good investment. All right, now they want to price it at $497. So let's see what the profit would be if they only charged $497 a policy. Doesn't look too good. I'm going to say plus $497. This is their profit, a negative $33. So it's really a loss. They're losing $33 with every policy that they sell. So in the long run, Avicennia can expect to lose money. And how much? $33 on each policy that they sell. So they either need to increase it to, I don't know, $531 to try to make a profit or break even, or maybe not sell these policies. Seems a bit of a conflict of interest or just crazy. All right.